Limits at infinity. What we're talking about is something like the limit as x approaches infinity of something. Right, so we are studying what happens when we push x to the outer limits. Okay. So
I should probably repeat that. I'm sorry.
we can first just kind of talk in general. What happens to the function x squared? As x approaches infinity, what happens to the y value?
Y squared.
Y up.
Okay, so it goes forever as well, right? What if I said, what's the limit as x approaches negative infinity for the same function?
Right, so it approaches infinity.
Yes, it's still going up to the infinite, right? It's not going down. It would be negative infinity. Okay. So, yeah, so we have a good picture of what's happening as x goes to infinity. Y also goes to infinity, right? Remember end behavior from last year?
Yes.
Yeah, that's kind of what we're looking at here. It's all it is. What happens to in the end behavior of the graph? Okay. So last year we would say as x approaches infinity, y approaches infinity.
Right.
Now you're just writing it in calculus format.
So,
Okay. The same stuff. We're going to get a little more detailed, obviously, because it's calculus. Let's try this.
Yeah, limit. Oh, wait.
Wouldn't it be infinity?
I don't know.
That'd be
It'd be
one.
sine infinity.
It would still be one, wouldn't it?
Yeah, sin x.
As x approaches.
Does
It doesn't exist.
No, what? I don't
Nope, it
know.
doesn't exist.
It's a wave.
Nope.
Why do you think that, Jeff?
Because nobody else is saying it and you haven't said anything.
because
It's not a bad inference.
Process of elimination.
Not the right answer, but it's a good inference. What happens to sine as you go to infinity?
The limit is one. but
Does
I
it
mean,
ever
it's-
stop going up and down?
No.
So does it ever approach any one value?
No.
So what's the answer?
Doesn't exist.
Thank you, Jeff.
Really?
Wow.
Pull all you.
And is that,
Okay, so Jeff got his.
will that work for cosine too?
Thanks, Damon.
That was rude, but funny. Okay, what?
Will that work for cosine too?
Cosine, same situation.
You hang it
Right?
up in your room, you hear me, Damien?
Okay. Yeah, so it just oscillates. There's no value that it goes to, okay? What we mostly pay attention to when we study limits at infinity are horizontal asymptotes. Okay. So I have a function.
what's an asymptote?
We learned this last year, but I don't think any of us remembered.
Here's your function.
That looks.
Oh, it's the line that it approaches but never hits, right?
Right.
Is that what an asymptote is? Okay.
We'll make this.
I'm gonna write that down. It's a good definition.
Yeah, so limits at infinity define horizontal asymptotes.
Wait, how's that top of the horizontal? If it hit
Ah,
2 points.
Because it's the end behavior, right?
all we're worried about what happened at infinity.
Okay.
Yes. It's an excellent question that he asked, because we usually as math teachers tell you that asymptotes means that the line never touches it, right?
That's not necessarily true.
It's not absolutely correct. You can touch the line, the horizontal asymptote, you can cross it. The
But
question is what is happening as x approaches infinity? Okay? So yes, this is still a horizontal asymptote.
Okay.
Even though it crosses it, even though g crosses it, is still a horizontal asymptote. Okay? And that's why I like to give this example, just for that one fact. Right. So the limit as x approaches 3, as x approaches infinity of g of x is 3.
Just kidding.
Right, because it's never going to cross it. So he's going to get closer and closer to 3.
I may have crossed it at one point, but it's never going to cross it again.
Right. What is the equation of the horizontal asymptote?
You just wrote it down.
No, I didn't.
Oh, you
Dang it. What did you say? Y equals 3. Pair those together in your brain.
Can the asymptote be like a linear function in itself?
That's exactly what it is.
Well, no, but like
It's
what if
slope
it was,
0.
like, it had a slope of,
We can have slant asymptotes, yes, but they're very nasty. Hyperbolas have slant asymptotes,
Ah, I'm glad I'm not going to be here for that.
but limits at infinity do.
what's that for?
Okay. We don't worry about those. What is the limit as x approaches negative infinity?
Negative
G of
2.
x?
They're negative 3.
Yep. Okay, and the horizontal asymptote is
-3. Y equals -3.
y equals negative 3, yes. Okay, again, pairing those up in your minds, right?
I got him covered.
Is that as, oh, HA.
EOHA.
Okay. Couple. What?
Will it always be like a single number? Will there be like an equation for a horizontal asymptote? Will it always be a single line? Or will it
Yeah.
yes.
I think so, if I'm understanding your question correctly. Okay. Here's a couple of basics.
Okay, you're good.
Thank you.
You're welcome.
Not often people tell me that.
Wait, didn't those already? No, wait.
What are the horizontal asymptotes of 1 over x?
0?
Infinity, because it gets smaller and smaller. Negative infinity. Because like,
I have 2 answers. One of them is correct.
-infinity.
It's either 0 or negative infinity.
-infinity.
Do we need to take a vote?
Wait, what did you, what was it? Repeat the
Wait,
question. Did you say horizontal asymptote?
This question can also be written. What are
Yeah, it never approaches 0, but not 1.
Wait, he asked what the asymptote was?
horizontal, or what, I should say,
Is.
what is, because there's only one, asymptote of y equals 1 over x?
It's 0.
Why do you change your answer?
Because
They have to match.
Because
I thought you were talking about what the limit was.
Right, and then I think
The limit and the.
Same thing, man.
The limit and that's totally the same thing.
What you're
Zero,
thinking
told
of
you,
is
Jamie, that's
as
2 in
y
one day.
approaches
What was that one thing where we were like?
Now you're not going to hear the end of it. What does the graph of that look like?
it's weird. It has the, I can't describe it.
It's a
with
rational
words.
function. Looks like this.
It is.
Remember your parent functions, that's why we studied them so much.
That's how I could describe it.
Limit as x approaches infinity? 0. Okay?
Just understanding.
Is that the same as the limit as x approaches negative infinity?
Nope. Yes.
Yes.
It'll still be 0.
Told you.
It still doesn't.
Nope, yep.
Yeah, they're the same. Okay, that's a pretty good pattern that you can rely on, of rational functions. Another, the kind of the way I want to coach you to think about this, maybe not graphically, x is getting really, really big, right?
Right.
What is happening to this whole number?
It's really, really
It's getting really, really small. It's going towards 0,
Yes.
right? So so think of it this way. As x gets, we're using math language here, really big,
Yeah.
1 over x gets really small.
So can't you just say as x increases 1 over x decreases?
Infinity, 0. That thinking will do dividends the next 10 minutes.
Sweet.
Okay? Pay you dividends. That's what I should say. Do you dividends. That doesn't make any sense. Okay. So you kind of have a good idea of limits at infinity and horizontal asymptotes, right?
Yeah.
Let's try something a little more complex.
Oh, wait, so it's one-sided limits now?
Go. The way we solve these is pretty genius, actually.
You factor.
Infinity.
No, you don't
You
even have
just
to do
plug in
that.
infinity.
It's
Yes.
0 over 0.
All you consider,
It's 0 over 0.
okay, all you have to consider are the highest exponents. Okay, that's it.
So since.
So I don't have to worry about any of this junk.
You only have to worry
So
about.
I am looking at, do not write equals here, because it's not appropriate. All I need to worry about is 20x squared over 3x to the 5th. That's it. This is not a formal
Wait.
math problem, it's a solution technique for limits at infinity.
I have a question. Is this because we're only looking at the end behavior?
Yeah, all we're
Okay,
looking at is
because
what's
that,
happening at the
like-
end, and these two high powers govern that.
Okay.
Right?
Because then you don't like, because that can go like in between.
Yeah, exactly. So what's the
I
answer?
get it. As x approaches negative infinity, it approaches.
If I'm going to
0.
positive infinity,
Isn't it the same as the one?
the
over
bottom's
x
really
problem?
big, right?
Yeah.
Higher power. I could simplify this if I wanted.
That's the same thing as the one over x problem, kind of, right?
Because
20 over 3x cubed, right?
Right, yeah.
Which is, that's 0, yeah? And it doesn't matter if it's positive or negative infinity, in this case. They both go to 0. Okay? Yeah, because that's a 3. That looks just like that 3.
Yeah.
Okay, so all you're looking at is the bottom bigger or is the top bigger? Third.
And if it was, if the top was bigger than the bottom, so it'd be approaching infinity, right?
So,
Yeah, that's why I do the snowman, but just he's taking a nap.
let's try another one.
The top is bigger though.
If the top is bigger, it approaches infinity. If the bottom is bigger, it approaches 0.
Right.
Wow.
Actual number. So, look at that with 0. I just get smaller and smaller and smaller. It approaches 0 across.
That one's true.
Is that positive infinity?
Okay, look at this one. What are we considering?
The highest
So
exponent.
next to the 3x equals
So it's gonna be 0 again, right?
Just the highest exponents, right?
Right. Your x has been canceled. I mean,
Yeah, these,
But your 7 is bigger than
27. Think of that Rocket function again.
There you go.
It's not
That's
zero.
The same power, it was still never quite approaching. It never.
The exponents are the same top and bottom, right? They can cancel. The end behavior will be the same.
So, but you have an asymptote of 3/7.
Your 3/7. So your horizontal asymptote is y equals 3/7. Okay? Yes.
That would be
So
as.
our problem, why would it equal to zero?
The bottom is infinity. It's really big, right?
Yeah.
Like if I write 1/1 billion, that's really close to 0. Correct? The next iteration might be 1/10 billion, 1/100 billion. It's getting closer to 0. That's what we're looking at.
So why is there never a point where it crosses 0?
Okay?
Because we have that many numbers that we can just keep adding those zeros.
Big denominator, we're going to 0.
It's because of that's why.
Infinite amount of 0.
All right. Let's try
There's
another
infinite
one.
amount of space between each. So,
Oh my God, please don't mention atoms. I knew someone was going to
I did not want to die.
Atoms, ADAMS or ATOMS?
ATOMS.
They're pretty useful, you know.
They are.
I like to watch them in nuclear explosions.
So if you guys last
I just don't like to experience those nuclear explosions.
You should accept it.
No.
I don't like that.
It's not
I
good.
don't like just accepting.
How do you not get that? Because at the end of the
Because, I mean, as if we're discussing life itself.
Is that 7 over 2?
Yep, 3x to the 7/2. Man.
Like calc or, I mean, 10?
Plus 7x, the negative 1/2, over x squared minus x to the 1/2.
If you didn't have nightmares for math, this would be with them.
So we should just have
No.
7x and no, the 3x and 7
7 and x and x squared.
Yeah, these two we don't even need to worry about, right?
Right.
So,
If we accidentally make it equal when we do this transition where we're going from the entire equation to just the highest exponents, do they mark you wrong?
technically it's wrong.
Do they mark you wrong for that?
Probably.
They might. So I would
So is that
just be mathematically correct and don't put equals.
3x to the 7th square root, or square root of 3x to the 7th?
So when you draw arrows instead of equals?
No, no, try and do it.
Just drop
You
your.
like show some sort of progression. Ah, yes, that's.
Sure.
That symbol?
Okay, so you cross that, yeah?
Not formal, but
Isn't 7 has bigger than 2?
Yeah.
Yeah.
Then you have.
yeah, so this is 3.5, right?
Yeah.
So that's bigger, so instead of
So
prohibition.
what's the
Approaching
answer?
infinity.
Here you go. Top's bigger, infinity.
Boom.
Or negative infinity, depending on odd or even.
So if the bottom gets bigger, then it's
0.
Then 0
Approaching
top
zero.
instead of infinity. Or it must be the numerator and the denominator.
Couple more. There's just lots of different little nuances that you want to be able to deal with.
Well, yeah, I don't like that one.
Roots.
Yeah. Roots can die.
Roots cannot die. It would kill the entire tree.
Good.
Maybe let's stop showing the map.
I feel like you
Oh
said
my
all
God,
about
there's
that.
a beautiful infinity.
I feel like you've said that joke before.
I haven't said it before, but it's pretty good. That's,
Do you actually have those where you set up a joke all years
Oh, yeah.
until the lesson where you make it?
Oh,
You bet.
I'm, like, my day has been busy.
So,
I'm sure our trip to Glenwood will be.
all right, what do you got? How do we deal with this?
Anyone can.
that gives you as the
Multiply by
of
the.
x squared over the square root of x cubed. Right?
Yeah, so the square root of x cubed is x to the 3/2, right?
Right.
Huh?
So it'd be approaching the
Square root of x cubed, you write it as a fraction, Which one's bigger, top or bottom? Yeah, so what's the answer?
Infinity.
Infinity.
Yep.
Is that infinity? Yeah, that's infinity.
How do you know?
Oh, wait, you don't have
Because
to worry about
it's
that,
the
do you?
square root of x cubed. The fraction that's formed is
We
3
should
over.
practice that for SAT.
Okay. How about this one?
Running out of room, man.
Yeah, me too.
Me too.
Whoa.
Spicy.
Tabasco even.
Tabasco's not spicy.
Zero.
Okay. Thank you for your.
It would be,
Well,
12x.
That's a separate example, right? I'm not.
It's separate, yeah.
it'd be 12 over 16.
It'd be 12x over 16.
Bottom
Just
is
rewrite it.
So it's just 12 over 16, right?
12x over
And then
16x.
square root of 16.
four.
Oh, 4.
Yeah,
Oh,
4x.
boogers, I skipped that
No,
part.
it would be
Ah.
three.
So it'd be infinity.
Boogers.
It'd
I
be
got
3.
plenty of those if you want.
It'd be 3.
We're talking about for the three. How do you draw that your x's and 12 divided by 4?
Okay, so yeah, dealing with roots, right? Square root of 6, this is the highest exponent in the bottom denominator. Square root of 16 is 4, square root of x squared is x. Now we see that they match. 12 divided by 4
Is there any event where we
Okay.
can like, so I identified that the exponent is the biggest inside the root, can I ignore all the rest of it right there? So I don't have to square root the rest of it?
Yeah. Okay, now here's something you have to be aware of. That's terrible. Let's do the same problem
So what?
to negative infinity.
Why is there a difference?
Same problem. Yeah, but you're.
It'd be negative.
-3.
No, wouldn't you choose the smallest?
-3.
Yeah.
Sure.
No, it would be -3. Oh, -3.
Boom, Damon.
We're still 12x over 4x, right?
Yeah, so it's still 3, yeah.
Oh, -3.
Here is where you have to be careful. You plug negative infinity top and bottom,
Negative divided by negative is positive.
right?
Still 3, yeah.
But the answer is -3. Why? You have to look at the original problem.
That's
What's going to happen when if I put a negative in here?
It's gonna turn into a.
It's a positive, and the top is a negative. That makes the answer a negative. Okay? You have to be very careful with these roots when you're doing negative infinity, okay? Just look at the original and think, okay, we have a positive negative issue here. Right, so the answer is -3 because this original makes that a positive. Okay? Just something to be aware of. All right?
You're on a roll, Jeff.
That's it.
I have a question.
Yes.
So if the highest exponent was like 100x, what would the square root of that be like? The square root of x?
Yeah.
It's like the square root of x.
100 root x. Or x to the 1/2.
Oh, okay. Yeah.
No. Okay, okay, okay.
Then we have that argument.
And then next week it's just test, right? Test review, test.
Next week is prep and test.
Test prep, test review.
I posted it on Classroom,
Yeah, so.
I think.
Please stop.
Are you gonna put the booger in your eye? What's it called, the back of the book on Classroom?
Is that one and two or
Alright.
Oh, 1 and 2.
Prelims 1 and 2.
It looks like a 4.
It does.
due Friday. Okay, so we're good there.
Hey.
That's a lot of problems.
14.
Prelims are all in the back of the book, the answers, like evens and odds, right? You've got 8 and 12 here, evens. Chapter 1, page 57, these are algebra problems.
To help us.
And 2.2 spiraling.
4.
4 and 8 you got. So you got 4 evens. Might want to know how to do those.
Mike.
Your first test is next week, right? So the study guide, I believe, is posted if you want to start studying. This year you do not get any memorization, or you don't get any blue sheet or anything.
You don't get a blue sheet?
Nothing.
Oh, I'm bummed.
Okay, so study those memory cards. We will make more tomorrow. We're going to make more memory cards tomorrow. Don't let me forget, okay?
Didn't they get a blue sheet last year?
Nope.
You're actually supposed to know the information.